In this video, I'll cover virtual machines, what they are, how they work, their use cases, and the most common virtualization software. I'll walk you through the hardware requirements, guide you through setting up a VM on your self-hosted server, and break down the key differences between the virtual machines and containers. Plus, I'll show you how to access your VMs remotely using Meshnet. So let's get started. A virtual machine is essentially a computer running inside another computer. It's a program that emulates a fully fledged physical machine while remaining entirely separate from the host system. Think of it like getting an apartment in a skyscraper. You can customize it however you like, get your own furniture, lock the doors, and even redecorate. But ultimately, you're still within a much larger building. Virtualization is the technology that makes it possible. It allows your computer to divvy up its hardware resources, such as the CPU, RAM, and storage, among multiple isolated environments. Virtual machines have a wide range of applications, especially in self-hosting, software development, and security. They're a great way to run self-hosted services like a private cloud, a media server, or even game servers. Software developers rely on them for testing applications across different operating systems without needing separate physical devices. They're also useful for running legacy software, so all their programs that only work on an outdated versions of Linux or Windows. Some people even use them for gaming, whether it's emulating retro consoles or running games on otherwise unsupported systems. Security and privacy are another huge advantage. Virtual machines act as sandbox environments, which means you can test potentially risky apps or even isolate a web browser inside a disposable VM for safer browsing. Now, when it comes to virtualization software, there are plenty of choices, but the three most common, in my experience, are VirtualBox, VirtManager, and Proxmox. VirtualBox is free and open source under the GPL v3 license. It's available for Windows, macOS, and Linux, making it a solid choice for general purpose virtualization and personal projects. However, if you want the extra features in its extension pack, keep in mind that they're only free for personal and educational use. VirtManager along with KVM QEMU is my go-to option for Linux-based virtualization. It's fully open source and leverages a kernel-based virtual machine, KVM for short, providing near native performance that's almost indistinguishable from running on physical hardware. This is a fantastic choice if you're setting up a self-hosted server. And then there is Proxmox, a Debian-based virtualization and container management platform that's widely used for self-hosted server setups. It's the choice of many users due to its robustness when it comes to managing virtual machines and containers, as well as its enterprise-class backup solution. What makes it even better is the ability to use it through a web browser. Speaking of containers, I covered them in one of my previous videos, so now let's clarify how they differ from virtual machines. Virtual machines simulate an entire computer, including its own operating system by virtualizing the hardware. Containers, on the other hand, only virtualize the software environment, meaning they share the host operating system while keeping applications isolated. And the best analogy I can give you, virtual machines are like separate apartments inside a skyscraper, while containers are more like different rooms inside the same house, sharing resources, but still maintaining some degree of independence, like most things in computing. Virtualization benefits from having more resources. The more CPU cores, RAM, and storage you have, the more VMs you can run or the more resources you can allocate to each one. The key thing to check is whether your processor supports hardware virtualization. Intel processors use VTX, which has been a standard on most models since 2015, though some exceptions exist, like certain Intel Atom chips. AMD processors, on the other hand, use AMD-V, and it has been supported by all Zen-based CPUs since 2019. Now, let's go step by step through setting up a Linux virtual machine on a Windows 11 host using VirtualBox. And while some versions of Windows have a native hypervisor called Hyper-V, others don't. So that's why we'll focus on VirtualBox instead. First, download and install VirtualBox. Head over to the official website, grab the installer, and follow the installation process. If the setup alerts you to missing dependencies, read the instructions carefully and install them as needed. Next, download a Linux operating system image of your choice, and I'll be using latest version of Ubuntu Desktop. The ISO file is fairly large at around 6 GB, so expect the download to take a moment. Once the download is complete, it's a good time to restart your computer, because VirtualBox might need to reboot to function properly. To create your new VM, open VirtualBox and click New. Choose a name and select your Linux ISO. For hardware allocation, ensure you allocate at least 2 GB of RAM. Then create a virtual hard disk with at least 20 GB of storage. If you run into any boot errors related to an unsupported graphic device, don't worry, it's an easy fix. Simply shut down your virtual machine, go into its settings, navigate to the display section and switch the graphics controller to a different option. And once you successfully boot into Ubuntu, the installation process will begin. This can take a little while, but once it's finished, you'll have a fully functional Linux virtual machine running on your Windows system. Now, if you want to access your virtual machine remotely from anywhere in the world, NordVPN's Meshnet makes it incredibly simple. Here's how. Install NordVPN on both your virtual machine and your remote device. Then, log in and enable Meshnet. And if you need help installing NordVPN on Linux, check the description for a step-by-step guide. Next, make sure the OpenSSH server package is installed on your VM. On Ubuntu, you can do this by running this command. With everything set up, you can grab another device in your Meshnet network and remotely access your virtual Linux machine through SSH using its Meshnet IP address. Virtualization is a game changer for self-hosting, development, and security. Whether you're looking for a safe testing environment, a private game server, or a dedicated system for hosting services, virtual machines give you the flexibility and isolation you need. And if you found this video helpful, leave a like and let me know down in the comments. Are you using VMs, containers, or perhaps both? Anyways, catch you in the next one.